Hello everyone, in this video we are going to solve question number 26 of GATE 2010 paper related to complex analysis. The question is the pole of the function f of z is equal to cot z at z is equal to 0 is a removable singularity, an essential singularity, a simple pole or second order pole. So in order to solve this question, we can write f of z is equal to cot of z. Cot of z is nothing but cos of z divided by sine of z. Now in the question we have four options. So the common approach using which we can arrive at one of the correct option out of these four options is that you do this expand this right hand side of this function using Taylor expansion about 0. So you expand both cos z and sine z using Taylor expansion about 0. So cos z is nothing but 1 minus z square by 2 factorial plus z to the power 4 upon 4 factorial minus to so on. Similarly, sin z can be written as z minus z cube by 3 factorial plus z to the power 5 by 5 factorial and so on. Okay, now what you can do is that you take numerator as it is, pardon me if I'm making some mistake in sign, but that is irrelevant over here. You take z common from the denominator and then take the rest of it in the numerator. So you can just write it to the power minus 1 because you're taking this whatever is left after taking z common, you're taking it to the numerator. So what you are left with is 1 upon z. F of z is nothing but 1 upon z. 1 is z square by 2 z to the power 4 by 4 factorial 1 minus z square by 3 factorial plus z to the power 4 by 5 factorial and so on. Now you just do, you keep this as it is and you do the binomial expansion of this thing. You'll get some higher order terms. You're not interested in higher order terms. And this is. Now you have simplified this function as much as you can. Now you find three things in this resultant equation. First, if the resultant binomial expansion or the resultant expansion of this function has expansion of fz has infinite number of negative powers then z is equal to z naught is called an essential singularity of fz. Secondary, if the expansion fz has no negative powers of z, then z is equal to z naught is called the removable singularity of fz. Now in this expression, if we just call it a, we can see that it does not have infinite number of negative powers. There are no negative power in fact. So it is not an essential singularity. And also fz, if fz has no negative power, but we know that there is one negative power which is 1 by z, that is z inverse. So if we just do the product of these two brackets, then we find that there is one negative power. So both these options, that is the function fz, that z is equal to 0, is not a removable singularity. This function at 0 doesn't have a removable singularity and also doesn't have an essential singularity. So the third is, in this expansion you find the coefficient, you just find the coefficient or you just find the highest negative power in fz. So in this case it is 1 by z. So this will give the pole and order of pole. So the pole is nothing but at z is equal to 0, which we have been asked, and it's a simple pole because its order is 2, because its order is 1. Suppose if the highest negative power was z square, then you could have said that we have a pole at 0 of order 2 because there is z square. So in this way you just have to do the expansion of fz and then find the highest negative power. That will give the pole and order of pole. So in our case we just have a pole of order 1 at z is equal to 0, which is a simple pole. So C option is the correct option of this question. Thank you for watching this video.